Hi everyone! So here is the Word document that you can open from the module. It has 4 different functions on it, and we're going to look at an investigation for each of them on Desmos that allows you to answer the questions listed on the left in the table. So I'm going to guide you through the quartic function, and then you can fill in the other 3. It shouldn't give you too much trouble. So first of all, look at the headings on this table. I gave you the base function for all 4 of them. Well, what happens if we were to transform these functions or change them by adding or subtracting other terms to it? And even more importantly, what would happen if we changed the number right in front of the leading term? That's the first variable you see raised to the highest exponent. So if you look under the linear heading here, you notice that there's an a. Well, that a value is important because it's going to determine what the graph looks like, and you'll see that in a second. So to transform each of these graphs, we need to give sort of a general equation, and I'm going to do that here for the quadratic, and you're going to see the pattern for the rest of them. I'm going to go ahead and enter an a in front of the x squared. That's our leading term. And then I'm going to add a term of x. So we're going to call that value b times x. So some number times x we're going to add to the quadratic. And then finally I'm going to add a constant. We're going to call that constant c. So there's the general equation for a quadratic function. And we're going to see what happens if we change around that number for a on Desmos in just a second. Let's do the same thing for the cubic and the quartic functions here. A is going to go in front of the x to the power of 3. Then I'm going to keep adding my terms in descending order or degree. So this is going to be bx, and I'm going to raise that to the power of 2. And then I'm going to add a c times variable x. And then I'll add my constant, which is d. And let's do the same for the quartic here. So this is going to be a to the power of 4 plus bx to the power of 3 plus cx squared and there you have it. So those are the 4 general equations for the functions we're going to use. We're taking the base functions and we're going to change them up. That's as simple as it gets. So let's go to Desmos. Here's the link for the linear function. So the linear function is easy to play with. I'm going to move over to the quartic link that you have there, and this is what you see. So if you notice in the first equation here on the left, this is the general equation that is in the table that I just entered. It looks a bit more spread out, but it's the same thing. Now this function is being graphed with all of these constants set to 0. And you can see that down here. B is equal to 0, C is equal to 0, etc. A, however, is equal to 1. So let's play around with this and see what happens if we change the A a little bit here. So if A is 2, or 3, or 6, or 8, you may not see much of a change, but those numbers can get bigger, or they can also be negative. So what if we change it to -1? Well, there's a reflection across the x-axis. You can change it to -10. You may have noticed a little bit of a stretch there with the function. It got skinnier. So I'm going to keep the a value as a 1 for now. Let's look at our table. I want to know the end behavior. If this says if a is greater than 0. Well, that just means if my leading coefficient is positive, what is the end behavior of the graph? Well, let's look here. Here's our quartic function. A is positive. What is the end behavior? Ask yourself, if x gets very, very large, I'll zoom out a little bit. If x gets large over here, what's happening to the graph? Well, it's going up to positive infinity. I can show that in my table. I'm just going to copy and paste an equation. going to state end behavior like this. If x approaches positive infinity, then what happens to the y value? Well, quite simply, y goes to positive infinity as well. Okay, so there's one end behavior. If we look the other way, so the quartic function, if x gets very, very large in the negative direction, the graph is also going up to positive infinity. So we can state the same thing. I'm going to copy and paste this below and change this up a bit. So if x is approaching negative infinity, y is also approaching infinity. So that's how you state end behavior, and that's how you analyze it from the graph. Now I want you to try the same thing, but this time let's make a negative if a is less than 0. So going here, I'm going to go to a. Let's make it -1. Where did my graph go? It's down here. I can drag it like that. Now go ahead and have a look on your table and fill in that end behavior for the quartic function. When you're done that, fill in the rest. Go back and do the linear, the quadratic, and the cubic function the exact same way. You can pause the video and come back when you're done that. So welcome back. If you finished the other functions, you can check your answers here. This will also be posted on the module so you can check it. I want to move on and look at the other questions that they're asking for. So the next one is for the maximum or the minimum value of your function when a is positive and a is negative. So those two different leading coefficients. Let's head back to the quartic function and we'll see what happens here. So in this case, notice that my a is positive. All of the other constants are 0, so I haven't transformed it yet. What is the maximum value of this function? Or in other words, what's the highest number that it reaches? Does it reach a highest number? Obviously not. This function keeps going on to positive infinity. So we can head back here and say there is no maximum. What about its minimum value? That's very obvious. It's actually the same as the x and the y-intercept. It's the origin. We haven't moved this function anywhere. So we can state that the minimum is at 0, 0. Now what happens if the a value is negative? Changing the 1 to a -1, this graph is reflected, and we get the opposite. So its maximum value is the origin, 0, 0. The graph never gets higher than that point there. Its minimum value, however, doesn't exist. There is no lowest number that it reaches. It just goes on till negative infinity. So we can say there is no minimum, but there is a maximum at 0, 0. The next one, the domain. Well, the domain for both types of the functions, whether a is -1 or a is +1, x can be any real number. If there's no restriction as to what x value I can plug in here, everything will work. So we can simply state, I will use an equation, and say x is an element of the real numbers. And that is the same for both. Now the range will have a restriction for the quartic function anyways. If a is 1, my range is restricted because the function cannot go past 0. There's nothing down here in the negative, so I have to state that. I will borrow from this. And we will state that y can be any real number as long as, and we do need to state this, let me find, y has to be greater than or equal to 0. And there's your range. If a is negative, the only difference is, again, that range. The domain is the same. the range will be such that y has to be less than or equal to 0. It's never going to be positive. So I'm going to put this here if a is negative. Actually, let's paste this one here. There we go. Change this. Y is going to be less than or equal to 0. So there's your domain and range. That's all done. The last question is asking, what are the minimum number of x-intercepts and the maximum number of x-intercepts that we can have for each of those functions? Caught that typo there. Let's go back to the graph. Now let's look at this. Let's make a equal to 1, positive. Now, how many x-intercepts can a quartic function possibly have? This is where you need to do a little bit of thinking and playing around with these numbers b, c, d, and f. So I'm going to show you what happens here. I'm going to make b 2. Let's make c 3. And let's make d 4. And let's make f, let's change it up, negative 1. What's happening here? Let me zoom in a little bit. This almost looks something like a parabola. Don't be fooled. There's a lot going on here that could make this look quite different. Let's change these around a little bit too. Let's make that a negative 2. Let's make C a 5. Let's make D negative 6. Still looks a lot like a quadratic. Well, here's a good one to look at here. B is negative 1, C is negative 10, D is negative 9, and F is negative 1. Look at what this looks like here. I'm going to zoom out. We have this very distorted looking quartic function whereby it goes down, it reaches a minimum, and then it extends up to positive infinity on both sides. But more importantly, look at the x-intercepts. Now how many do you see? 1, 2, 3, 4. They're actually highlighted on Desmos, which is a nice feature of that program. You can click on them and it'll tell you exactly what they are. This type of transformation tells us a lot about a quartic function. It says that at most there's going to be 4 x-intercepts, and that should be intuitive because of the degree of the polynomial. If the degree is 4, it can have at most 4 zeros or 4 roots. So let's put that here. The maximum number of x-intercepts, we did that first, for a quartic is going to be 4. But what about the minimum number? Well, let's set everything back to 0, except a. Let's keep a 1 or negative 1. And let's look at this graph. Well, there's 1 0 right there. But what would happen if, you're probably thinking this, we moved this graph up? Let's say we moved it up by 2 units. I'm changing f at this point. This graph does not have any zeros at all. So it is possible for a quartic function to have no roots or no zeros. And so that will be our minimum number of x-intercepts. And notice that those numbers don't change if a changes. If a is negative, I could easily move this down by 2 units, and we still have no zeros or no roots. So the same pattern occurs. Spend some time and play around with these different variables and create your own quartic functions. See what different numbers do to the graph. When you're done, go back and fill in the rest of the chart for the other 3 functions. And very important to check your solutions when you're done.